Good morning, guys. Today we are going to be talking about Chapter 11 Equilibrium and Elasticity by me, Jan Philippe Am. Our first problem, a brass wire is to withstand a tensile force of 350 newtons without breaking. What is the minimum diameter the wire must have? So, for our given, we have a force of 350 newtons and we have a required of what? Diameter. We're looking for diameter. So this is a diagram I drew up, and the first thing we have to do is look for the ultimate strength of brass. Now, if you look it up, it's going to be 4.7 times 10 to the 8th newtons per meter squared. So we know that our ultimate strength is equal to force over our cross-sectional area, which would be pi r squared because it's a wire. So if you use a little bit of algebra, you can look for your r, which will give you square root of force over pi times UBS. Now if you plug everything in, you will get 4.87 times 10 to the negative 4. But you have to multiply that by 2 because we're looking for diameter. So our final answer will be 9.74 times 10 to the negative 4 meters, or 0.947 millimeters. Okay guys, for our second problem, you are trying to raise a bicycle wheel of mass m and radius r up over a curb of height h. To do this, apply a horizontal force F. What is the smallest magnitude for the force F that will succeed in raising the wheel onto the curb when the force is applied? A. At the center of the wheel, B. At the top of the wheel, and C. In which case is less force required to get the wheel over the curb? So, we have a given mass equals m, radius equals r, and height equals h. And all we're looking for is the force. So, given the diagram I drew up, we are looking for the lever arms and the forces. So we have the normal force mg multiplied by our L, which using the Pythagorean theorem is square root of r squared equals a minus r minus h squared equals F, the applied force, times r minus h. So all we have to do is isolate F, which will give you mg times square root of r squared minus r minus h squared all over F times r minus h. So now we're looking for the top of the wheel. Now you notice all we really have to do is change r to 2r, because instead of the center of the wheel being our r, we just double it because we're applying it on top of the wheel, so we're actually getting the diameter. So all you get is F equals mg times square root of r squared minus r minus h squared all over F times 2r minus h. Okay, so for C, all we can say is less force is needed on the top of the wheel. Now why? Because if you look at the formula for torque, you can see that the further you are from the axis of rotation, the greater your torque is, because it's F times the lever arm. So as you can see, instead of R, when we're applying the force on top of the wheel, you are doubling it, meaning instead of just R, you have 2R. So that means you are further from the axis of rotation, meaning you're applying a greater torque. Okay guys, for our last problem, end A of bar AB rests on a frictionless horizontal surface, and the end B is hinged. A horizontal force F of magnitude 102 newtons is exerted on the end A. Ignoring the weight of the bar, what are the horizontal and vertical components of the force exerted by the bar on the hinge at B? So, we are given a force F which only acts on the horizontal plane, which is equal to 102 newtons, and all we are looking for are the horizontal and vertical components exerted at point B, which is the hinge. So, it's important to note that the system is in equilibrium, so the total torque, the net torque, is 0. And you can notice right here that this is a 3, 4, 5 triangle. So we can note that the force being applied multiplied by 4, which is the lever arm, minus the normal force, the vertical component, is multiplied by 3, which will give you 0. So all you have to do is find the normal force, which is 4 times 102 divided by 3, and which will give you 136 newtons. And for the horizontal force, since it's in equilibrium, we can note that the horizontal forces cancel out, so the only force acting at point B on the x-axis is 102 newtons. So we have our f of x and f of y, and that is all we have for today. Thank you guys for listening. I hope you guys enjoyed, and till next time,